Okay, make this a real quick video. This first example is very simple. Silence of the Lambs. Okay, quota sampling. This is a sampling. Continuing on with 9192, where you have a fixed sample size. And the sample size in quota sampling represents your population proportionally, let's say. So you must represent the overall population proportionally. This is what I'm sure a Gallup poll tries to do. I don't know if we call a Gallup poll necessarily a quota sampling, but a Gallup poll tries to poll people of the United States that represents the rest of the United States proportionally. You'll see how this one goes and how that works. And I'm not taping the whole thing for the tape because it's pretty simple. Now I know Mrs. Truesdale revised the numbers that Mrs. McGrath found in 2007-8. I was lazy, I'll just be honest. But she went to you could very easily go to our grade software, or actually just on the Lockport website, I think it's for all of us, the district report card. And we could see how many students there are currently and the demographics of those. And actually she found it real quick when we were sitting together last week discussing this stuff. So somewhat interesting. And as you write this example down, something else I found interesting, keeping the 2007-8 data, we thought these numbers were going to go up drastically. And that's why anyone ever hear of the referendum of trying to get another high school here, going through that rigmarole? This is like my fourth year teaching here, third year, I think. 4, 5, 5, 6, 6, 7, fourth year, I think. I think I started 04, 05. And we thought these numbers were going to go up to 4,000, 4,200, 4,300, and we were having a real crunch here space-wise. Well, the numbers actually leveled out and went down for a couple years. Anyone know why? Something that happened right around these years? Something crashed? I don't know what these people are saying. I don't think any of them are saying, though, the housing market, finally someone said it. Okay? I don't know what those guys were saying over there. Okay. Housing market crashed. The last hour we talked angrily about that. See the movie The Big Short? Anyone see the movie The Big Short? That's not the movie. No. Oh my gosh, I'm stopping for a second, taking a break. Oh boy, I don't even remember how to use this program. Oh, here we go. Okay, shh, annoying. Okay, so here we go. I'm gonna zoom in. Very simple, and I'm not taping this whole thing. So what was the big number? 3879. So we have 3879, but we only want to survey for some random reason. Again, where did that number come from? I have no idea. We want to survey 751 of them. We want them to be representative of the population that we have at hand. So, very simple. Boom, boom, boom. African American population back in the day, there was 237 out of 3879. Native American, there's only 31 out of 3879. Blah, blah, blah. I'm going to write all these down and get what percents they are with the help of the class, of course. And we'll do that offline. So we got those. The next step is to take these percentages and multiply them by 751 to figure out how many of these 751 should be African American to represent 6% of the population, which is what that means. So multiply all of these by 751 to get a representative population. A population that proportionally, I guess, is a proportional representative of all these demographics of the full population compared to the 751. We'll put those numbers down next. And what you should do is leave this all the way out and then, so I should have told you that as we did this. When you get this 0.061 blah blah, that's why I have the dots, we didn't round. Just take that full thing, multiply by 751, and then round mathematically. And then these numbers will guarantee to add up to 751 if we round appropriately mathematically. Okay, hopefully we rounded correctly numerically, and hopefully this ends up being the number of students that we ended up wanting to have. No, it doesn't actually. So I'll go to, okay, we'll say McGrath's written notes. She writes nicer than me anyway. For stratified sampling. Now I wrote this for the other class. Strata um, simply means like group or put them together in something. All right, strata. Strata is a group. So stratified sampling is group sampling. The population is subdivided into two or more non-overlapping. This means they don't have anything in common when we put them in these separate groups. No person can be in both groups. Each stratum, each group, should be more homogeneous, which means alike, than the entire population. So you have this entire population. You decide to group them by something, some idea, something that they have in common. And it's distinguishable where someone doesn't end up in both groups. It's a combo of quota, which is the grouping, and simple random strategy, which we're going to go back to that where we need our little charts. I'm not going to pull the charts. So this is going to be so great for the movie, but I'm not going to pull a chart because that was kind of hard to do. It's that chart, figure 9.4 on whatever page. The reason I printed that out for you was so that you didn't have to keep paging back and forth between the homework that you're doing and this chart that you need to access numbers from. You get a stratified sample, you write down the 1, 2, 3 from McGrath's writing. Very nice and neat. Separate the elements into different groups, strata. Determine how many elements need to be come from each stratum. You don't know what that means yet until we actually do this question, but it's kind of similar to the last one, where you want to represent each group proportionally. Right? Then you select an SRS and select individuals from this. So this is picking individuals out of this after we're done. We didn't really do that in the last example. Like which specific people in the Lockport example are we going to survey? So they stopped short on that. So we just selected how many would come from there. This one we're actually going to pick the people. So here we go. Boom. There it is. That was just the one. Nope, that doesn't show up in class, but does show up online. Boom. Okay, so here's the setup. And then what we're actually going to do when they say this last part is we are going to pick individuals out of each strata or group. Okay, and then that's the scheme we're going to use. So there's 156 patients, 75 are expecting their first child, 54 are expecting their second, 27 are expecting their third. There's your strata. First child, second child, third child. Make this real simple. Draw a line for each one of these. Ooh, that might not be good enough for that one. Okay, this is your percentage representation. There are 75 children in the back. Please stop throwing around your pencils and papers. Thank you. This is a senior class. Okay, someone get me the percentage. So 75 out of the 156 are having their first child. They're expecting, this is their first. Okay, so it's 0.28, blah, blah, blah. Is that right? 0.48, sorry. Well, you just had to divide, so 0.48, da, 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 da. And then what we're going to do is we're going to randomly have 25 total people use this new drug or whatever. 48% of them should come from the people that are having a child first. We're trying to represent the population that way. So we're going to multiply that by 25. How many people should come from this strata? I think what we got in the other hour is 12 women. And then round mathematically. So round, in that case, down. Now we're going to select them. So what I didn't leave enough room for, I don't know why I turned green here. That's not going to change. Let me try to get it all. There we go. Make this all red. Now we're actually going to select them. And I made this look ugly. So what we're going to do, why is it green again? Okay. Is pretend there's a list of these women, and we're going to number them 1 to 75. And now we're physically going to select them using this what's called scheme, this simple random sampling idea. We're going to start at row 103 from figure 9.4, the piece of paper I gave you on Friday. How many people are absent? Anyone absent? I have them up here. This is to help you in your homework right up on the podium. And then this is just a random number generator scheme. Use the third and fourth digits from the third column. What's the first number that you see if you follow this? I'm waiting for someone in the class to actually do it. 23 is right. If you're not found, you're not following the scheme. It's very easy. What's the next number you see? 20. What's the next number you see? These are all people in the list. So you've numbered these random people 1 through 75, and now we're randomly selecting them using the 103rd row, third and fourth digit. What's after 2? 0 doesn't work. 65, correct. And so on and so on and so forth. 23 is the next. No, it's not, because 23 is a what? Repeat. Go back. Okay, so 23. 93 is not a person. 42 is, though. That's 5 people so far. 31. Okay, so you need to be looking at this figure 9.4 using that random number generator to get these. We'll write the rest offline. Now you get it. We'll do the rest probably offline. I'll do the next one green. But one thing to pay attention to is stay at 36, where you're in the third row. You're actually at 120. Look across. See that? For the next one, we're going to keep going from that point to get how many should come out of the, this is their second child, strata. 54 out of 156 is the representative population. We turn that into a decimal, and then we multiply that by 25, and then that tells us how many women we should be selecting from here. Okay, we'll do all that offline. So we have 9. We do number these women. I'm going to erase this, get this out of the way, write it in a different color. Number these girls 1 or women to 54 again, and you're continuing on from that 36 you found from the previous list. Now remember, these are 54 different women. They're in the second strata, and you'll number them 1 through 54, and then go from there. 54, isn't that the first one? And 29? 50 what? Okay, those are the numbers generated, and those are the women selected for the trial. And the third one we could do completely offline, but we'll say, how many were in that? I cut it off. 27 out of 156. Same old, same old. So we're going to select 4 from this list, and we're going to number them 1 through 27, the third people, and we'll put what those numbers are after this. Okay, so continuing on from that 02, I should have put 02 and 07 on those, but we'll fix that now. And then you go from there. You don't have one? You have some Friday? Okay, and then cluster sampling, I'm going to go back to McGrath's because it's a lot, and she writes nicer. Look at that. Isn't hers so much nicer than mine? Whatever. Okay. Then cluster sampling is not a big deal. There's a lot of words. You don't have to necessarily write them all. It's very similar, but the grouping is a little bit different on this, I guess. Sampling units. So students are it's going to be students. That's why I have that in my mind. But this clustered in groups for no reason. It's not a specific reasoning like the last one, last two, where they had similarities in their groups. But they're non-overlapping subsets. They may vary in size. One or more elements are in them, and there may not be a reason for why they're in those lists. I guess a frame, that's a new word to me as well, is a complete list of the clusters. And from that, you're going to pick X amount of clusters for, let's say, randomization. Get out. Seriously. You can't stop. I'm literally online on YouTube kicking a student out of my class. He cannot stop yipping and yapping. It is more important what he's talking about every single time. Every single time. Let's go. What he says is more important than anyone else's education. No. Okay. All right. Sorry you had to listen to that ugly incident. The previous two were a fixed sample size. We wanted 751 lock per people. We wanted 25 women to test the drug out for whatever, for the having a baby. But I guess in this particular example, there is a minimum requirement. So there might be, but the way the clusters work, you have a group of people in each cluster. So we don't have an individual fixed requirement because the clusters can be randomly different in size. And you select the cluster, not the individual. That's different from the last one. We put them as individuals after we grouped them as what types they were. So here's an example using some old math teachers' names and Doornkot should be spelled with an N, right? I get sued for this. Their name's online now. For billions to see. So here's what we have. Say you're at the dean's office, wanted to do this. Randomly first hour, let's pretend Lockport's a much smaller school. Dean's office says, you know what? Let's do a survey. Let's randomly select from classes. So there's only 6 classes during first hour, these 6. They want to study the effect detentions have on decreasing tardiness, and they have some sort of thing, some sort of pamphlet or something you fill out or something. They want to have at least 48 students picked out of this. So you look at all the classes. First of all, how many clusters do they need in order to make this 48 students thing occur? How many clusters would they have to select? 1? Would 1 cluster be enough? Would 1 class be enough? Yes or no? No. 2? 2? Why? 2? What is 2 classes no matter what? Even in the worst case, Doornkot and Garrett. How many students are together in Doornkot and Garrett's class together? 48. Barely 48. So actually 2 clusters would be enough out of these 6. So they number these 6 classes. And then we're going to create an SRS, simple random strategy, a scheme, I just like to call it, from our list in order to select these randomly. So 2 would be needed, and 3 is the scheme. And it's just like in the questions, they always give you what the scheme is. They tell you what to do. So you go to row 128, and you just move across. The first number in row 128 is a 4. Anyone else that's looking, what is the next number? What's the number after the 4? 0. 0 is not a number that counts. So then you go to the next one, which is a 2. So 4 and 2 are picked, which is the 2 as mentioned there, which ends up being 61 students total, but they're all going to be taking the survey then, and then they can make up something about the results.